We're going to do the polygon review at this point. So first of all, we're going to review the names of polygons. So a three-sided polygon is a what?
Triangle.
Very good, a triangle. A four-sided polygon is a
Quadrilateral.
good, quadrilateral. I do expect you to spell these correctly. So make sure that you copy this down correctly so that you can learn the correct spelling. Now remember, for quadrilaterals, we have certain special quadrilaterals that have more specific characteristics. So we have trapezoids, we have parallelograms, rhombuses, rectangles, squares, and kites. We have all of those that are examples of special quadrilaterals, but each one of those has four sides, so it is a quadrilateral. Quadrilateral is the term for any four-sided polygon. Okay, a five-sided polygon is a, very good. A six-sided figure, we have two appropriate names for a seven-sided figure.
Heptagon.
Okay, so let's parse that out. So a heptagon is what you will typically see in most textbooks. Heptagon. And a septagon is the other acceptable name for a seven-sided figure. You will see that in some textbooks. Okay, an eight-sided figure is an
Octagon.
very good, octagon. A nine-sided figure is a nonagon. Ten-sided figure, an 11-sided figure, it's just 11 dash gone, but we don't read the dash, we just read it as 11 gone. 12-sided figure, very good. So we take the decagon from 10 and we put a dough on the front of it. So we're adding two more sides to the decagon. Make sure that this is an A in here. Okay, and then last but not least, N is not the name of any particular polygon. This is the format for any of the polygons that we have not written a more specific name for. N is the variable that stands for the number of sides. So you actually have to plug in for the number of sides. If you had a 17-sided figure, it would be a 17 dash gone, which you would read as a 17 gone. So be very careful there. The answer is never just N gone unless I'm asking for a formula. Okay, so now we're going to review our interior and exterior angles. So first of all, we need to figure out how many sides we have to this convex polygon. So 1, 2, 3, 4, 5. Okay, so we have a pentagon here, and we know that our formula for the sum of the interior angles of a convex polygon is n minus 2 times 180 degrees. And we know that all of the angles in that have to add to this because this is the formula for the sum of the interior angles. So I'm going to say, okay, so we need to add all of the angles together. So I just start with one of them. I'm going to go around. So I've got 2x plus 84 degrees plus 2x plus 110 degrees plus 90 degrees as indicated by that 90-degree angle. Okay, so now we have to plug in and figure out what this is over here. So we had 5 sides. So we have 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180 is 540 degrees. We have 2x and 2x, which makes 4x. Plus, we need to add this together, 84 plus 110 plus 90 is 284 degrees. I'm just going to bring this down. So now I need to solve this. So I'm going to subtract 284 degrees from both sides of my equation. So we get 256 degrees is equal to 4x. Now I need to divide both sides of this equation by 4. And ultimately, I determine that x is equal to 64 degrees. My x is equal to 64 degrees here. 4. Problem number 2 asks us, each interior angle of a regular polygon measures 135 degrees. How many sides does the polygon have? What is the name of the polygon? So first of all, we know that our formula for one interior angle of a regular polygon is n minus 2 times 180 degrees divided by n. And so I know that in this case, this is going to equal 135 degrees. So I need to solve for n. There's more than one way I could do this. I'm going to set this over 1 and then cross multiply. So I have 135 n is equal to n minus 2 times 180. Well, I have a number multiplied by a binomial, meaning two terms inside parentheses, so I need to distribute. So I have 180 n minus 360 degrees is equal to 135 n. So I'm going to subtract 180 n from both sides of my equation, which gives me negative 360 is equal to negative 45 n. I'm just going to carry this equation up here so that we can see our work. It's negative 360 degrees is equal to negative 45 n. Now I need to divide both sides by the coefficient of our variable. So I'm going to divide both sides by negative 45. And I determine that this figure, we have 8 is equal to n. So we have an 8-sided figure. And we know that an 8-sided polygon is an octagon. You could check the table if you needed to verify that. Okay, problem number 3, we're asked to find x here. Now, we're dealing with exterior angles here. We know that the sum of the exterior angles of a convex polygon is always 360 degrees. So I can say 360 is equal to, and I just have to add my exterior angles together. So I have 150 degrees plus 90 degrees plus x equals 360. So 360 is equal to 150 plus 90 is 240 plus x. So I'm going to subtract 240 from both sides. And x equals 120 degrees. 4. Okay, problem number 4. Each exterior angle of a regular polygon measures 40 degrees. How many sides does the polygon have? What is the name of the polygon? We know that our formula for one exterior angle of a regular polygon is 360 degrees divided by n being the number of sides. And in this case, we know that the answer to this is 40. So how I'm going to solve this? Well, I can put 40 over 1 since it's a whole number and cross multiply to solve. So I have 40 n is equal to 1 times 360. Divide both sides by 40. N equals 9. So I have a 9-sided figure. And a 9-sided figure, we know, is called a nonagon. So we have a nonagon here, a regular nonagon, 9-sided figure.